and welcome back, everybody. How are you all doing? Omega Given here. We are live and going to be talking a little bit about basics of programming today because it was requested, and I think this is an awesome request for all you guys to learn a little bit about where to go from here, especially for those youngins that want to know should you go to college? Should you not go to college? That's a whole debate in itself. But I just want to give you a pathway that you can follow and stuff like that. So as people start trickling in, because this is a live thing, but you can rewatch this and skip through parts if you want to. We will get all set. Let me check my audio really quick though. From here, especially for those youngins that want. Okay, I think the audio is good. Let me know if if anybody joins in live, if the audio is bad or anything. But with that said, let's talk a little bit about basics of your path of programming. What do you want to do? Do you want to be a software developer? Do you want to be a game? All right, so you want to be a software engineer where you're making applications that do bigger, broader things, or do you want to be a programmer where you're just programming video games? Because those are two completely different things. They use a lot of the same basic essential stuff, but it's still very solid stuff that you can look into and do and use. So those are two ways. You could go into programming thinking that you want to do one of those two things, but end up doing just anything related to computers, like IT. You don't really need a degree to do IT stuff that much. Employers will pay you more if you have a degree. So I guess that's something that's nice. That's weird. My headset's all weird right now. But those are a few of the things. So what do you want to do? Most people will start off being I want to program video games. That sounds like the best idea ever. And then they try to do it, and it's a huge market that just, it's filled. It's a very filled market, and it's really hard to, get into that kind of market, because what do you have to do? You have to literally program video games on your own, until somebody comes along and finds your video games and they think you're impressive enough to hire them into their bigger development studio. For example, I do want to play, program video games myself, but how I'm going to go about it is I'm just going to literally work my normal software development job and get basically my living, everything in my living, and then from there I will then make actual software development studio, where I maybe try the very first game on my own, make a game, put it on Steam, maybe put it on Oculus, depending on how I optimize it. Then after that, I will hire on some people to help develop sequels for games related to it, and so on and so forth. And that's only considering I make a profit, I turn a profit. So you gotta think about it, yes, you want to make video games, but really, essentially, in life, you need to make enough money to live. So that's your primary number one. So how can you do that? How can you pursue these options of life? One, you start now. You start learning, you start growing on your ideas and development now. That is essentially number one that you should do. How I started was literally 5th grade. My brother, he built his own computer. I saw that. I thought that was cool. He gave the computer to me after he left high school and such. So I had that computer, and I had a computer that at the time, this is 15 years ago? A little less than 15 years ago. I used that computer to just play video games. I learned a little bit about development. I played Minecraft when it was way old. This is less than 15 years ago. It was way old back then. And I was just dude, this is awesome. So I learned how Minecraft works. I tried to do a little bit of modding in Minecraft back then. Did a whole bunch of other stuff like that. So, that stuff is ways to start. You want to break down the rudimentary of how things work and everything. And this is where I have a hard time, because a lot of people hate hackers. But hackers are oftentimes people that are just trying to understand that they're oftentimes people that are, well, for one, it's bad to do things that are, destructive. But they are at least learning a little bit. And sometimes if it's kids that are being hackers. But with that said, hacking's not a good thing, but it still is a way that you can at least learn. So you got red hat hackers, white hat hackers, or black hat hackers, all that kind of stuff. But just you want to learn. You want to find methods of learning. I think some of the best methods of learning is literally just watching tutorials and just trying to program a game to start off with. Another way I started doing some more bigger time programming was I got into financial programming. So I developed an algorithm that read stocks and is like, should I buy or trade stocks for these days and such? So I kind of did a program like that. I could do a whole series on how that works. We won't do that today. I'm just going to start out with stuff, trying to do relatable things for you guys, which is programming video games. So we'll do that there. What's some other stuff? I think that's about the main gist of it. Oh yeah, as far as getting a degree, before I get into the actual, like, let's talk about like actual programming and like some basics. I think I'm gonna do a two-part series kind of. Today I want to talk about basically the syntax of programming, and that can range widely depending on what programming languages you run. But we'll talk about syntax. But with that, what was I saying? I was talking about degrees. Yes, you need a degree for a lot of developers, a lot of people to take you seriously. But sometimes people will hire you on if you even don't have a degree and you have the skills. So that could just come with literally doing a lot of stuff. Because what I learned with my 4-year degree was I did not need my 4-year degree. That's what I learned. I did find it very helpful, but the amount of money spent on my degree and time spent on my degree could have been used more wisely if I knew my direction in life. And that's one thing that degrees do for you. They help direct you in life a little bit. So if you don't know your direction in life, a college degree can direct you in where you want to go. Because I started out wanting to do cybersecurity, but then I went on to be like, okay, maybe I don't want to do cybersecurity. Maybe I just want to do like development of softwares in robotics. And then from there, I went on like another year of college, and I went on and be like, no, I want to do financial program, which is where I started with stocks and stuff. And then from there, I'm like, okay, this is what I want to do, and I found a job in that sphere. I'm doing financial programming. So with that said, let's move on to our second topic. But first, let me thank our sponsors. Omega Given, my other channel, is our sponsor for this thing, because this channel is very soft, or small. I mean, soft. Why did I say soft? I don't know. But yeah, you guys should just go check out my other channel. If you're from the other channel, thank you for stopping on by and all that stuff. Actually, speaking of my other channel, I'm gonna post this video in my other channel because we need more stuff. I need to have this in my other channel. Okay, let me, hopefully I can get this to work. Alright guys, so we're going to be talking about syntax here in just a second. So when I say syntax, the word syntax actually just means basically a language of programming of some sorts. And that can change. Live on my other channel now. Okay. Actually, wait, let me... Alright, okay. Alright, I had to just post to my other channel. Okay, so let's talk about syntax. I'm gonna go over to my desktop view, and we are going to talk about syntax, because syntax is good. Alright, so what kind of syntax here? Let me open up like a text document. I don't know. This is gonna be called syntax. And I might just even Google some syntax for us to learn, or like to think about. So our topic of syntax. Let me make this way bigger because this is like teeny tiny. And also fill the screen. Why not fill the screen? And okay. So we have syntax. What kind of syntax do we have in programming languages? Well, syntax is kind of like the means to use the programming languages to your benefit. For example, you have if-else statements. So like if something, a condition of some sort, and then do this, else do this. So if it doesn't fulfill the first condition, does the other condition. Some languages use like else if. So you might start a sentence like if blah 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 blah, then do tab in, do blah 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 blah, then else if. So it's on the same line of code, blah 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 blah. You do tab blah 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 blah, and then finally it ends with an else. So that's what the else is. If else blah 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 blah. So that's kind of like how you do if else statements a little bit. or so that's like the two things. You can just do if else, where you just cut out this whole middleman right here. Oh, whoops. Let me I just undid all my work. Yay, that is so helpful. All right, whatever. So you have if else and else if else, and then if you want to expand that, you could do else if. I think that's two methods of doing those things. So what's some other things that you could do? You can, I'm just kind of talking about conditioning kind of stuff a little bit. There's while statements. So you can do while some condition, a condition. A condition is where it's like, what's a good condition? While true, aka forever. That's oftentimes what a while true is. Forever do this until something returns false. That will end a while true statement. So that is one way to end a while true statement. Or you can just do while omega equals, or omega dot live equals true. I don't know. You could just do something like that, where it's like while omega dot live equals true. Like maybe there's like if there's a property of omega or of live under the object omega, it'll do whatever condition. So that's a while statement. What's some other stuff? We got if else. We have switches. Switches. Some languages don't have switches. Some languages do have switches. Switches is basically a if statement, but like expanded. So it's like while condition, do if the condition is equal to true, then do blah 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 blah. If the condition is equal to 10, do blah 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 blah. If the condition is equal to I don't know, hungry, do blah 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 blah. That's basically what a switch statement is. It's just an expanded if statement. Some languages don't have them. I don't think Python has one. I think there might be a library we can import and you can use one. But yeah, that's a switch statement. What's some other stuff? We have class. Okay, here, let's get into the nitty gritty of some real stuff. So there is objects. What is an object? An object is basically something that stores properties. Something that stores properties. How you create objects? You use classes. Classes create, or a class. Well, let's use the word class, because a class creates objects. Classes are the definition of a object and used to create objects. Here, let me like tab this over and do that. So you have objects, where something that stores properties, and you have a class where it's the definition of an object and used to create objects. Now, what does that mean? It means that when you create a class, say in Python, you might do class character, meaning you have a object of characters that you can create with this class. Now, how do you do that? Well, you need to create one. So you do, this is kind of what it looks like in it. And then some kind of base properties. And then you just do a whole bunch of assignments of properties. So that's kind of like how you do a class. So what you do is you can call this little thing that I just created here, and it's just like, okay, I'm going to create a character object. So calling the class creates a character object, because the class is a definition of an object, in that it will put the base properties, the definition of that object. The definition just means like what it is, like what is, like what it contains, all that stuff. Does it contain the properties of health, damage, hunger? Is it a boy? Is it a girl? It can be anything. It's just anything that like works. So yeah, that's basically what a character is, or a class is. So now create an object. How do you create the object? Well, you call, say you want a variable. We're gonna make player one equals character. This is how you call the thing, and then the character's name is gonna be Omega, and it's gonna have health, or 10 health, it's gonna have 10 damage or whatever. And what we do is it takes these properties, and it will do right here, this is init. This is how it defines itself, or how it gets defined. It will take it and put it in here, and then it'll assign it all and everything. This is not exactly the exact how you do it, but it's basically a way how it does work in a way. So that's basically how you can, what classes are. Classes are very helpful. Almost all languages use classes. There's different ways of how languages run, but the classes are very, very, very helpful across most if not all languages. So that's classes. Now let's talk about the next thing we can talk about. Okay, babe. So the next thing we can talk about is defined scripts or definitions. So I'm going to be doing this all in Python because I think Python's a really easy language to start off with. So in Python, you can define a script or a line of code that runs when you call that definition, that script. So you call def for define, say, do this. You can literally call it anything, or let's just call it addition or add. We'll call it def add. Technically there is actually already stuff like add, so you do def add and this is a definition of scripts. Definition of a script. It's basically where you put a lot of scripts or a lot of code under some name. So you can call that name. So you can call that name. I don't know if that makes sense. So you can call that name. So we can call the add to run whatever's after this. Like we tab in and we can run whatever's after this. Say we need add x comma y. So we have x and y. How do you add them? Well, guess what? We can just do x plus y, return x plus y. That's literally all we can do to do add. That's how you do it. It's just x plus y. And the computer will know what addition is, so that's easy. We're literally just using the computer's definition of add. And you can do subtract the same way. You can just make this subtract and make this minus. So instead of doing, I don't know, some weird formula, say if we wanted to do a full-on formula, we could literally put the whole formula in here. Like, for example, if we wanted to make is the Pythagorean theorem, or is that one something we could do? Here, give me a second while I pull up something we can use. Pythagorean theorem. Yeah, let's do this. So Pythagorean theorem. A squared plus b squared equals c squared. Let's do that. Actually, you know, we might do that in today's stream, like on the actual thing, not just here. So that's, or actually, okay. Before we get into actually coding stuff, let's keep covering more syntax you might need to know. All right, so those are a lot of the bigger, broader syntaxes of how stuff works. Now, there's a lot of small syntaxes, like specific syntaxes that are like properties of certain things. Like, let's just use numbers. So what kind of numbers, like computers store, or programming languages store numbers in what kind of form? They can store numbers in integers. Integers is like 0, 1, 2, 3, 4. They're whole numbers, aka whole numbers. Then you can store them as floats. So a float number. So a float number is like 0.000 or 1.000 or 2. Blah 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 blah. Those are all floats where it adds a decimal, basically a decimal value. I probably am spelling these wrong, but whatever. Number. So we got integers, floats. There's a few others. I'm trying to remember off the top of my head. There's a few other ways to store numbers. I can't think of them off the top of my head, but there are, and it's very easy to figure out what they are. You can literally Google them in the moment and know what they are. But like, there's just ways to store like larger numbers, smaller numbers, and stuff like that. Integers is oftentimes the easiest place to start. Floats. Oh, a double. The double is what number? I can't remember actually. What's the difference between a float and a double? See, this is where in this profession you can just literally do float. What is a float number? Let's just do that. What is a float number? Integers and floats are two different kinds of numerical data. Blah 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 blah. Here. So yes, those are integers. Blah blah blah. Oh, maybe floats are actually something different. Doubles are okay. What is a double? What is a double? See, this is where you can just Google all these things. What is a double in C, C++, C Sharp, aka just programming in general? Let's see. You can use Google to do anything. 64-bit floating point data. See, there you go, floating. I guess a float is a little different than just a point value. A float is a little more specific to certain things. If this thing ever works, I don't know why this is... I don't know why it's being all weird. Alright, I don't care. Float is basically the same thing as one, or float is a decimal value. Or, I mean, a double is a decimal value. Well, correct me later if I'm wrong. I'm just like going off of, like, I don't have a lesson plan for this. You kidding me? I'm not a teacher. I'm just teaching you guys in the moment. Alright, so we got numbers. That's how you do numbers. Alright, now we have strings. Or a string. What is a string? A string is characters. Yes, there's characters in programming, aka oftentimes you put strings in quotes or single quotes or something like that, so you can either do that or that. So this is a string, or in some languages you can use single quotes. This is also a string. So this is how you can store, full lengths of things. Now, in some languages, strings are not just always strings. Strings are actually lists. What is a list? Well, a list is something where it stores values in a list. It's a thing that you can, iterate through and use for, other stuff. So, you can store a name in a list. So this is like omega. You can store omega in position 1 of this list. And then maybe in this second position, you can store my description of omega. And why I say that strings can be lists in certain languages is because when you look at this is a string, or actually let's do something like this is let's just do that. Okay, string. That could literally mean that the programming language thinks this might be a lot to type out. H, like that, but I'm gonna just do the first couple words. I, comma, S, comma, space, comma. So this could, and so on and so forth. So that's how some languages store some of these, lists. It would store, it would literally store it in each place value. So if you want to iterate through the string, say you want to check some spelling, you want to be like, okay, let's go through the first word. Basically, you check, all right, position 0, T, H, I, S. Does it spell a word? Oh, yes. Okay, if it doesn't spell a word, is there a word similar to TH, blah, blah, blah. And you can create formulas that, just check that stuff, and that's how you make spell checkers and such. And then you can split it on the spaces or something like that. So that's how sometimes strings are lists. But yeah, you can make a list of numbers, just 1, 2, 3, 4. And if you want to, and one thing to know, most 99% of programming languages, if you're looking for a position, so list 1 equals 1, 2, 3, 4, 5. This is gonna get real confusing what I'm about to say. So if you wanted to access this list, you call list. Depending on the language, it could be like this, or it could be like list. Oops, I need to use list 1. You can either store it like that, or you can store it like, or sometimes languages do this, where it's like brackets or parentheses. It really doesn't matter. You have to figure out what the language does to call lists. That's where just a simple Google search can tell you, or whatever. So that's how you can do lists, is you call it, all right, this will call the 0th position. Most lists start from the 0 position. So this is actually 0 position. So if I call this, that will equal 1. If I do list position 1, that's actually going to call 2, because lists start from 0. They don't start from 1, they start from 0. So when that's like a little funny thing that a lot of programmers are always talk about, is oh yeah, you gotta, counting doesn't start with 1. Counting starts with 0, because the 0th position is the first position in a list. normally. Like 99% of languages do that. Some languages do something a little different. They might do like one as one, but we don't speak of those languages here. Those are desecrations to the idea of programming. All right, but that's basically a list. So what do we got? Well, we got lists, we got strings, we got numbers, we got definitions, we have classes, objects, switch, while, if else. What's some other big things I might be missing? We have there's a couple of other big things that you can use that are kind of like a list, like a dictionary. Actually, you know what it's called, right? Dictionary. There are dictionaries, and just like, you know how a actual physical paper dictionary stores a bunch of names with, or not names, or a bunch of strings when you think about it, and then what the strings mean as a secondary, it's the exact same thing as a dictionary. Basically the exact same thing. Dictionaries can often be defined, actually if you start with JavaScript, they use dictionaries a lot. So dictionaries can equal literally, you open bracket, or at least most languages it might be an open bracket, and then what you do is you have values in there. So you might have character, and then that character, or like a character of a string, and that character of a string can have multiple values. Like that character can have, I don't know, damage equals 10, health equals 10 or 20. I don't know. You can do a bunch of stuff like that where the character value, so you can be like, hey, in my dictionary, maybe you can call it, so in my dictionary, I want to retrieve this character. I want to retrieve character, and it will return a character object, or character equals dictionary, blah blah blah. So you can retrieve that character out of that dictionary, and then that character you can then be like, what is, or like return character dot health, or damage, I mean damage, and that will return 10, because it's like, it stores that, oh, damage is part of this character, so it'll store that. So dictionaries are a way of storing objects sometimes. Dictionaries can also just store just anything in values. You can assign something to this, and it's just a way of storing it. Dictionaries are very, very helpful. I didn't use dictionaries until like my second or third year in college, and once I started using them more, I started realizing, excuse me, I started realizing how helpful they were. So dictionaries are a very helpful thing. I oftentimes would say that you should use dictionaries over lists, depending on what kind of data structure you're looking for, like what kind of data you're using or dealing with. But yeah, that's basically dictionaries. All right. What else can we talk about? I think that's a lot of the basics. If you can, use everything here and practice everything I just said here, you will have part one of, I guess, all of programming, really. Like the rest of it you can literally just Google and practice. Part two of programming is how to use these things. I'll show you a little bit how in Python in another video, but I think this is a good 30-minute lesson on this, because I think that with this lesson of teaching you guys these things, and then my second lesson of just showing you how to apply it in a programming language, you can basically just do anything at that point. I think even my second lesson will be in Python, but I might make future lessons in other languages, and it'll show you how, you can get these basics done in literally under an hour, and you might just have to refer back to your notes and everything, or refer to Google, and you can program in basically any programming language. You can get very skilled to the point where you don't have to Google, which is why a lot of people like specialists, because it takes time to Google. So if you're hiring a programmer, you want a programmer that can just go crazy and program a ton of stuff all at once and understand everything that they see really similarly. Like where I work, I work 8 hours a day. I maybe write code for half an hour, maybe an hour. Then my other 7, I have a lot of meetings, but I have maybe 4 hours where I literally do research. Half of my day is research, aka I am Googling things, figuring out how to do things to do the 1 hour of actual coding that I'm doing. That's basically what it's like to code, really. It's just something that you just do and you practice and blah, 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 and all that other stuff. So yeah, that's basically how it works. I don't think I had too many people to hop on the live chat and nobody's really asking questions, so I think I might just conclude my lesson there. But this is the basics of programming part 1. I guess I don't have it part 1. But leave comments down below if you have questions. I'll probably do future live streams like this if it becomes more demanding, and people want to learn a little bit more. How does this, actually, let's do a little final conclusion. How does this relate to wanting to, like, knowing these things, how does it relate to wanting to be a game programmer or something like that? If you're not a game programmer, this relates very 100% directly to any other programming. Game programming, you actually can program without knowing any of this information, but this information is very helpful. For example, in Unity, whenever you open up a plane or a game, it probably has one plane and an object. You can give that object properties. That object is a object. It's literally using the exact same things that we learned here. So you have a sphere that is a object. That object stores properties. You can give it color. You can give it a property where when you press X or where you press W, it moves forward. When you press S, it goes back. Where you assign a joystick value to it, it can move around like a joystick, like how it moves. That's literally what it is. You can cause collisions. So if that object interacts with another object, it does something. AKA, when it sits on top of the plane, what does it do? It sits on top of the plane. It doesn't bounce off. It doesn't fling in some weird random direction. That's literally, it uses these same principles. You don't need to understand all these principles like 100% to do that kind of coding in Unity, but it helps. And for Unreal Engine, it's the same way. It's literally, they use these kind of things. And they oftentimes even have in their own programming language. I think Unity uses C# as its major programming languages, but you can use other programming languages on it as well. But yeah, C# and Java are very similar. Python is more of a database kind of, or a data processing kind of language, or that's oftentimes used for that. Like if you want to play video games, you're probably not, or if you want to program video games, you're probably not going to use Python. But Python's a very good starter because you can go right into it and program some random stuff. Like maybe I'll show really quick. It'll only take a couple minutes how you can run a Python script. Or so you can run, or you can get software to run Python scripts. Like some IDEs, interactive development environment. We'll be using that next part. Or you can literally just run it from a thing. So you do have to download your programming language, like Python. This is how you download, or this is Python downloaded. It's just a console where I can just do 1 + 1. It operates like a calculator, or I can just do def add. This actually might not work the same. X and Y. Oh, whoops. Invalid syntax. There we go. And then we tab in, return X plus Y. All right. So what we can do is we can do add 1, 3. How was it going to return? 5. It just returned 5. See, we just programmed something that literally adds 2 numbers together. If we didn't want to do, 2 + 3. We could have just done that directly. This is one way you can interact with a software script thing. Another way is you literally can just write it in a text document. This is the most easy thing ever. Is you can just literally open this up and you can put your def, which is very small, def X or add X plus Y or whatever, and you can just do, or X comma Y, and then whatever, return. The thing is about this is you don't know exactly what your syntax is. It won't give you errors or anything. Return X plus Y. So this is one way you can program. You can literally save this off as like a file, save as, and then just be like, instead of a text document, you want to make a py document, or that's how Python works. It's a py, py. And you can just save it like that. I think it's on my other desktop. There it is. That is my py file. So I just made a py file, and I can run it. I can run it in Python, and it runs it. There's nothing really to run because it's just a definition, but you can run it and it does stuff. For example, here, let's oh, I didn't even save it. Whoops. But whatever. That's basically how you can run it. That's just, that's very basics of how you can start out doing scripts, is you can do stuff like that. But I'd recommend getting an interactive development environment, IDE. That's sometimes the easiest way. We'll be using PyCharm in my next lesson. my little next tutorial, oops, that's JetBeans, PyCharm is the one I'm going to use to show you guys how to use Python. You can use anything really. There's some online ones. You don't even have to download some stuff. So you can just find out which ones you guys want to use. I'll just use PyCharm though. If you guys have watched this video up to now, thank you for watching. Please like and subscribe. This is my tech channel. We try to do stuff that's a little bit, that's not just video games and stuff like that. And we try to give you reviews of products. We try to teach you how to do stuff that works with businesses, stuff that turns your stuff into businesses, all that kind of stuff. All right. Thank you guys for watching. I'll see y'all next time. Bye.